Hello everyone, today I would like to talk about proving identities. Previously, we learned that the item on top is called a polynomial. For the second and third item, we can see that there's an equal sign in them, so we call them an equation. But within equations, there's one special type, which is called identities. Out of these two, which is the identity? On the left side, 6x plus 4 equals 22. We first put like terms all together on the right side. Moving the terms, we have 6x equals to 22 minus 4. We keep on doing this, moving the numbers to the right to do a division. X equals 18 divided by 6, we get x equals 3. If we put x equals 3 back into the original equation, 6 times 3 plus 4 equals to 22. This means x equals 3 is the solution to this equation. For the equation on the right, let us first deal with the brackets. We first expand this by times the 2 into the terms in the brackets. After expansion, we get 6x plus 4 equals to 6x plus 4. If we keep calculating by moving the terms and grouping like terms together, we get 0 equals 0. Why does this happen? Here in the second step, after expanding the brackets, we have already realized that the left-hand side and the right-hand side are exactly the same. This means no matter the value of x, the left-hand side will always equal to the right-hand side. Therefore, we call the one on the left an equation, and the one on the right, we call it an identity. What is so special about identities? Well, they have several special characteristics. The first one is that the left-hand side and the right-hand side are exactly the same after rewriting or simplifying both sides of the equation. The second is that an equation which can be satisfied by all values of the unknown. This means that no matter the value of x, this equation still holds. So that is what you call an identity, because it is satisfied by all values of the unknown. In order to show that this equation is actually an identity, we would normally add an extra stroke here to have 3 strokes instead of 2. So it's kind of like putting a lock into this equation. This lock shows that the left-hand side already equals to the right-hand side, so you do not need to do any more simplification to prove that, oh, the left and the right are exactly the same. Let's try an example. This example asks us to prove that x plus 4 minus 1 equals 5x minus 1. This equation is an identity. As mentioned before, there are 2 characteristics of identities. The first one is that the left-hand side and the right-hand side are exactly the same after simplification. The second is that no matter the value of x, this equation can still be solved. There are an infinite amount of numbers. X could be a positive number, a negative number, a decimal, a fraction. There are no way to try all values of x. This means we need to prove using the first characteristic. Let us look at the equation that we have. On the right-hand side, the 2 terms are already different terms. They cannot do any kind of arithmetic. However, there are still like terms on the left-hand side that we can operate on. So the first step is that we copy down this equation. Let us first calculate the like terms in this equation. X plus 4x. X has a hidden 1. So 1x plus 4x in total, we have 5x's. 5x minus 1. You can see that the left-hand side and the right-hand side are exactly the same. Then we can conclude, because the left-hand side equals the right-hand side, therefore x plus 4x minus 1, we add a line to show that it is an identity. It is identical to 5x minus 1. This is an identity. The next example, we need to prove that this is not an identity. The method to do it is exactly the same as the previous example. We first look at the left-hand side and the right-hand side. The right-hand side only has x, so we can ignore that. For the left-hand side, we can do some operations to simplify it. Our strategy would be to first group them together and see if we can calculate x. We first copy the left-hand side, but when copying, we realize that there is something that we need to use that we have learned when we were kids. Do you remember how to do fraction, addition, and subtraction? We first need to do something first. We need to take the common denominator. Even though there are unknowns in this equation, the way to take the common denominator is exactly the same. The one on the left, we can keep it, 5x over 6. But the one on the right, we need to do an expansion. The denominator times 2 equals to 6. The numerator, we need to do the same. Times 2 equals to 2x plus 6. When the denominator is the same, this means we can add them up together. We get 7x plus 6 on the top. Remember, do not do any simplification with a 6 in the bottom and a 6 on top. You cannot do this unless the sign in the middle is a multiplication. This is a plus sign, so we cannot do any simplification. 7x plus 6 over 6 is already the most simplified form. Very clearly, you can see that this is very different from the x on the right-hand side. Therefore, we can prove that since the left-hand side is not equal to the right-hand side, therefore, this equation is not an identity. That's the end of today's video. If there's anything else that you do not understand, feel free to ask your teachers or go to the math room. Goodbye.